Good morning, colleagues, ladies and gentlemen. Thank you for joining us this morning for the workshop. So as Tony has said, today we are focusing on sample selection techniques. We did touch on it, but it was in a rush in the previous workshop. So for today, the focus will be on the techniques, and then we'll go through some examples so that you can have a practical feel on how to select the sample. I will highlight that the topic of today is not on sample size determination. The following workshop will be on sample size determination. Today we are focusing on the techniques to select the sample, and then the follow-up will be now, how do you determine the sample size? So the outline, I'm going to start with an introduction, and then we will talk about different sampling approaches that will take us to probability sampling, non-probability sampling approach, and then we'll talk about sampling errors, and then I will highlight several things in my summary. Just as an introduction, I will just start with the process of conducting quantitative research, just for us to see where today's workshop fits in. So you will start with your problem statement, where you will be able to then formulate your research questions, and then be able to say what is the purpose, be able to say what are the benefits, what do we benefit, how are the consumers of your study going to benefit from your study, what value is your study adding, and then you can do the theoretical things, the literature, the assumptions, and then identify your variables, the variables that you want to measure in your study, and the hypothesis. Obviously, the hypothesis will be linked to the research questions. And then you, in terms of your variables, you need to be able to define them very clearly, and also go to the level of saying operationally, how are you going to measure them? How are they operationally defined, and how are you going to actually measure them? Then following that, then you can now explore a design that will be able to suit your research questions, and then outline the methodology that you will be using now. In terms of the methodology, that's where you will be specifying your sample selection approach, your data collection approach, your data analysis approach, and then you will finally conclude with your interpretation, your conclusions, and your recommendations. So as a starting point, we will just look at a population. Remember, when we are doing studies, we are interested in studying something that is within the population. So you want to measure something that is occurring in the population. So there is a population that you are interested in. So the population is all sets of units which meet your criteria of investigation. So you will know as a researcher that this thing that I want to measure, this is where it occurs. These are the possible units which have these characteristics, or which might have these characteristics. And then you will be able to now define and say, my population of interest is this particular population. I'm excluding this, I'm including that. So you need to be very clear with regards to what is included in your population and what is excluded. So the exclusion criteria, in essence, it specifies the units that are eligible to be included in the study. That will now lead you to the actual population that you need to focus on. And your inclusion criteria, it has to be very explicit, and you have to be guided by the correct definitions, the definitions that will work for your study. In many cases, things are defined differently, or things can assume many definitions. So you as a researcher, you have to arrive to a point where you say, for my study, this is the definition that will work. And based on this definition, I need to exclude these people or include this other group. Sometimes the exclusion and the inclusion criteria is not really based on the definition. Sometimes it's based on practically. For example, as a master's student, you do have limitations with regards to how far you can really take your study. You have 2 years to complete your study. So those limitations will also maybe drive you to exclude other groups, or yes, to exclude other groups where you see that if you include them, maybe the scope will be bigger and you won't be able to complete within the required time. So in terms of definitions, I've used those examples to say, for example, if you want to look at teenage pregnancy, and then the definition that is out there maybe will say it's those who are between 10 to 19 years. When you look at that group and you really think about it, you can see that they are all over. You might find that some of them are already at tertiary. Those who are 19 years, they are already at tertiary. Some are at junior primary school. Some they are at senior, not junior, I mean senior primary school. You might still find maybe a few who are still at junior primary school. Some are at senior and some are at high school. So when you look at that definition, the way it's presented, then you have to now apply your mind to say, will I be able to carry out such a study using this definition? So you might now have to say, as I've said, to say for the purpose of this study, I'm going to exclude, I'm going to maybe focus on teenagers who are in high school, or I'm going to look at those who are in high school as well as those who are at senior primary phase. So when you break down your definitions, it also assists you to scope your study properly and to also make an assessment of whether you will be able to execute the study, or if the study needs to be modified to suit your circumstance. So I'm posing a question to say, suppose you want to conduct a healthcare service satisfaction study. When you just think about that, so the way I've posed it, it's very out there, it's very broad. It's not giving you, it's not saying this is the focus. So, but maybe in some cases you might know that you want to look at a particular geographic area. So what comes to your mind in terms of the possible target population? I was hoping that I would be able to see your thoughts on the chart with regards to when I pose something like that, what comes to your mind with regards to a potential target population? I'm just going to pause for a minute to give you a chance to think about that, to say, if we look at customer care, or yeah, it is customer care in terms of health. So hospital, maybe if we restrict it to hospital. So we're looking at customer care in a hospital context. What comes to mind when you think about a possible target population? What things are coming to your mind to say, perhaps I can include this, perhaps I can include this? What are those things that are coming to your mind when you think about a scenario like this? I'm coming back to the charts to see your responses.
Yes, Miss Masondo, they have started to respond. One is saying patients.
Okay, I'll go back to the correct view. Patients, okay, I hear patients. I'm struggling to show my presentation again. I must say what, send live.
We can see it. We can see it. Maybe if we can put it on presentation mode, but we can see it. Another one is saying patients in a specific area, for example,
Okay. Okay, patients in a specific area. So you might think I will target a specific area. Yes. Other thoughts?
It's only those two responses for now.
Okay, so yeah, so you'll think someone did mention a geographic location. Maybe I can focus on a particular geographic location. And then in our South African context, you might be thinking, am I focusing on one particular hospital? Or am I looking at public? Am I looking at a private hospital? If it's private hospital, am I looking at the entire group? If it's a group, or am I gonna look at different groups to compare them? And if it's also public, is it restricted maybe to maybe a district where I look at the hospitals within a particular district? And then you have to think, okay, I'm looking at patient satisfaction. Am I looking at inpatients or outpatients or both? And as you think about them, you must also be thinking, for example, you are thinking outpatients, where will I find these people? Inpatients, I think it's obvious that you will find them within the hospitals that you would have selected, but the outpatients, you have to think about that. In some cases, you will find them in those institutions, in those hospitals, where some hospitals do have an outpatient. It's very demarcated, an outpatient section. So you know if you want to do a study where you can potentially find those patients. The other question is, are you looking at the patients, or will you be looking at the visitors, or both? Because if, let's say, yeah, for example, if you are looking at patients, inpatients, what about patients who are not in a position to talk? Are you considering interviewing their next of kin, meaning their visitors, and who qualifies as a next of kin? And are you going to consider questions about frequency to actually say, I can actually include this person as a respondent because they've been visiting the patient so many times, so they are familiar with the care that has been given to the patient? Are you excluding, if you're going to do inpatients, are you going to exclude certain wards and include others? So these kind of things, once you start thinking about a problem like this one, you now explore all this, and then you tie them to what you want to achieve, and then you'll be able to now include, exclude, until you arrive to something that will be suitable for your study. In some cases, you have a wish, but the environment does not allow you to actually execute what you have exactly the way you want to execute it. So sometimes it's not because you actually wanted to exclude a particular group, it's just because practically it will be very difficult to include it. So one thing that we must also take into account about a population is that a population that you are interested in, it might be homogeneous or it might be heterogeneous. That is very important for you to know as a researcher. What type of a population am I dealing with? Is it a population where my elements have similar attributes. When we talk about attributes, it's always in relation to your topic, because they can have similar attributes in relation to something that you are not interested in. It's similar attributes in relation to what you are interested in. Or is it a population where there's there are a lot of there's a lot of variation in terms of some of the variables that you are interested in? That is very important in terms of sampling, because if your population has a lot of variability, then you need to take that into account when you do your sampling. So you need to understand your population. You, as the researcher, you need to understand your population very well so that you can take that context and apply it when you select a sampling scheme. So a homogeneous one would be one where there are similar attributes in terms of what you are trying to measure. And the other one would be the instances where you find that there is a lot of there are a lot of differences. So we are now moving to the sample. So there is a population, which is what you are interested in, but we do know that populations in most instances, a population is usually big, such that you are not able to actually enumerate or collect data from all the elements of the population. It's not possible, it's not practically feasible for you to actually collect data from all the elements of their population, leading you to now having to select a sample that will represent that population. So a sample would be a subset of a population. So from that population that you are interested in, you will select a subset of the units, and then that subset constitutes your sample. So when we talk about sampling, it is that process of selecting a certain number of population units from a defined population. So the population has to be defined, as I explained at the beginning. You are selecting a subset, a certain number that you have decided on based on some guidelines or based on sampling theory. So the sampling technique would be the technique that you will be using to actually select the sample. So we have a sample. In some cases, the population is not that big. You can actually enumerate everyone, or you can actually collect data from all the elements of the population. In that particular case, we would say your study is a census. If you are able to collect data from all the elements of your population, then that study would constitute a census. However, if you have to select a sample, then you are doing your study would now be based on a sample. In a census, I think for those who are in South Africa, we are aware that there is currently a census that is, I think now they are trying to mop up, meaning they're trying to reach those areas where they were not able to reach in that allocated time that they had allocated. I think from the newspapers, I've read that in Western Cape, they've struggled to make headway. So they're doing a lot of mop-up in Western Cape. And also, I also saw that in high walled areas, in estates and in complexes, they struggled to gain access. So they are still trying to mop up and see if they can still count those people. I think you are aware, which is also the other thing, the other reason why sometimes you would do a sample. Obviously, a survey in this case, the country, we need to have a national count of all the people who are in the country. But in other instances, we do a sample, a study based on a sample, because you can see as a researcher that if you do a census, you might not do a good job because of the magnitude of the work that is required. So you might find that there's an undercount. There are people that you are not able to reach. You are not able to collect data from everyone. As a result, that compromises the quality of your study. Whereas if you do a sample and you are able to do that study very well and execute it very well, then that would be much better than actually doing a survey, I mean a census, but doing it not having adequate resources, maybe in terms of, and also maybe experiencing many challenges. So that's the other reason why we do a sample, because of the magnitude of the work that is involved in doing a census. But I mean, if your population is small, then you can go ahead and actually do a census study. So I think I've mentioned in what I've just alluded to, that in terms of the purpose of why we sample, it's so that we can have a representative subset of data, and so that we can be able to produce estimates of parameters. So there are parameters that we are interested in the population, and those parameters, we want to measure them. So we collect a sample so that we can get estimates of those parameters from the sample. The interest is in the population. We use the sample to see what is in the population. We assume that our sample reflects the population, meaning our sample is a representative of the population. We assume that what we are observing, what we will be observing from the sample, we can make generalizations. That in most cases, there are studies which are descriptive in nature, where we don't want to make inferences, but we just want to describe things. In those particular cases, it might not be a train smash if there is your sample maybe is not that representative, because you don't want to make generalizations per se. But when you want to make generalization, meaning when you want to take what you are observing from your sample and paste it on the population, then that sample needs to represent the population. It only makes sense that you can make generalizations on a sample that actually mimics the population. And we do sample, as I've said, because of operational costs, and also to be more efficient, to focus our resources to ensure that the outcome that we have is it's clean and it's not accurate per se, but it's very close to the actual picture, because you can never have, when you are estimating, there will always be room for error, but you want to be as close as possible to the true values that are in the population. So a sample is a representative of the selected unit of a population. We want to make inferences, as I have said. The more representative the population, the higher the accuracy of the inferences. So how you select the sample will also determine the population to which the research findings can be generalized. So the how you are going to select your sample will influence the generalizations which you can make. As I have said, in most cases, we want to make inferences. We want to generalize. How you select the sample has a direct relationship to what the inferences which you can make at the end. So the how you select your sample is very important. You need to bear in mind that this is what I want to infer my results to this population or to this group. As a result, I need to take certain things into account when I select my sample. So we have two sampling approaches. The one approach is a probability sampling scheme, and the other approach is a non-probability sampling scheme. So those are two approaches. When you get to your when you are explaining your methods, and you get to your now sample selection, you are explaining the methodology. You need to now, the first step that you will have to pass is whether is your sample a non-probability sampling scheme, or is it a probability sampling scheme? If you are going to be doing a probability sampling approach, you require a sampling frame. You cannot do a probability sampling without a frame. What is a frame? I will explain it in detail in the next slide. But a frame is a list of all population units which meet the inclusion criteria. So for you to do a probability sampling, you must have access to a list. Sometimes the list is a list in the actual sense, as in you are given a database that has a list of the units, the elements of the population that you are interested in. So you have access to a list, maybe a database, or you're going to request it from whichever source where your population is located. In other cases, the list is naturally occurring, like if your list is, for example, if it's houses. So the houses will be listed, especially in urban areas in South Africa. You will find that there are street names, there are house numbers. So you are able to actually know this is house number 1, number 2, and so on and so on. That can constitute a list when you know that I have these houses on the ground. But you need to actually go to the ground and actually see for yourself how the layout before you actually do your sample, to understand how those houses or those units are laid out. When you have a list, because you have a list, you know I have 20 houses or I have 30 houses. You know what is the probability, what is the chance that one house is selected. So every member of the population will have a known probability of selection. Because I have a list, a comprehensive list, I know when I select one, I'm selecting one out of 20. So the probability of selecting one house out of those 20, each house will have a 1 out of 20 probability of selection. I think if we go back to tossing a coin, you only have 2 outcomes, which is a head or a tail. So if I toss a coin, it's either it's gonna land on the head or it's gonna land on the tail. So there are only 2 outcomes. So a head has a 50% chance because there are only 2 outcomes. So it's 1/2, which is a half. And the other option, which is a tail, also has a 50% chance because I can either have a head or a tail. If I toss one die has 6 possible outcomes. Either it lands on a 1, a 2, a 3, a 4, or a 5, or a 6. So I have 6 possible outcomes. So if I toss a die, each of the outcomes, they have 1 out of 6 probability of actually occurring. So that is the whole concept of knowing the probability of selection. Because you have a list, you know if I select one unit, what is the probability that that one unit will be selected randomly from all the possible units. So there is a known non-zero. In most cases, it's the probability is equal. With the example that I gave with simple random sampling, which we will look at, the probability will be equal, meaning that if I select one house out of 20, all the 20 houses, they have 1 out of 20 probability of being selected, though they have an equal chance. No household or no house is favored there. They all have an equal chance. There are other instances where the probability is not equal. For example, I know when they do business survey, they will say So they will group enterprises into size. So they will have the big enterprises, the medium, the small, and the very small. So you will find that the big enterprises, I think they say large, they are in size group large. You will find that they will say in that group, they don't sample. Everyone who qualifies, who meets the criteria of being a big enterprise is included. So those enterprises, all of them, they have a probability of 1, meaning you know they will be included. Your big enterprises, they are all going to be included. Then when it comes to your medium enterprises, then they will sample there. They don't have a probability of 1. So you will see that the ones in the first group, they have a probability of 1, so they don't have an equal chance, because when you come to the other group, they are not selected with certainty, meaning they are not included by default, but there is some sampling that happens. Not all of them are sampled. So I know most people, when they say probability sampling, they always say an equal chance, but there are instances where the chance is not equal, but we do know the probability. They might not be equal, but we can quantify it. That's like the very distinction of a probability sampling, is we know, we can say, what was the probability? What is the probability of me being in this study? You can give a person that probability. And sometimes those probabilities, we can use them also to adjust in cases where maybe we do not have, let's say there was stratification, meaning you were grouped and they sampled from that group, and some people from the group did not respond. They can use the people who responded to adjust for the non-response, to say, because you were in the same group, you were grouped because you had similar attributes. Now that the other people have not responded in this group, then we can apply some non-response adjustment using your weight to say, because you have this probability of being selected, what is your weight in this sample? So every person or every unit that is selected will carry a weight, and then that weight can be used to adjust for non-response. And also the weight is also used to actually make estimations, to estimate whatever we want to estimate. With a non-probability scheme, it doesn't require a sampling frame, and the population of selection is unknown, so it cannot be quantified. Those are the clear distinctions. First, you must ask yourself, do I have a frame? Is there a frame that is available, or can I create one? Once you arrive at a point where you know that you do not have it, you're not going to have access to a frame, you cannot create it, then you know that your option is now a non-probability sampling scheme. So with a probability sampling scheme, there is some form of randomization to ensure that the units, they are evenly distributed in terms of some attributes that are inherent in the sampling units. With a non-probability scheme, on the other hand, there is no randomization. So in essence, because we said we know the probability of inclusion or the probability of being sampled, the probabilities, they are assigned to each unit objectively. On the other hand, the selection of the sample is made on the basis of subjective judgment of the investigator. So it's not really objective, but it's based on the judgment of the investigator. And obviously, because there is no randomness, it's sometimes called non-random sampling. The other one is sometimes called random sampling, probability sampling. So going back to a frame to just put more meat on it, as I have said with probability sampling, you need to have a sampling frame. So it's either the frame is existing, meaning that you know that, okay, I want to survey teachers. So I can access the Department of Basic Education if that is the correct department, I don't know, or if you have to access DPSA, I'm not sure. So you can maybe access the correct department and then they will be able to give you a list. Then you have a frame, a sampling frame. And the sampling frame obviously must have some attributes which will make you understand the population better or which will assist you with your sampling. Because having a frame is the first step. You still need to decide on which sampling approach am I going to use. And the variables that will come with the sampling frame, besides the list to say this is staff number, you know, in terms of maybe they are given in terms of staff numbers, some other attributes attached to those people will also assist with your sampling. If you don't have a sampling frame, can you create a frame within your time limits and your other resources? And then you need to ensure that every element of interest is in the frame. So it's about the frame being complete. Obviously, this is the guideline, but we do know that there are cases where, I mean, for example, if we were to think about here at UNISA, I'm not sure if you were to go to HR today to require a list of staff members. The question is, would you find the list to be up to date today? How often do they update the list? So maybe you might find some staff members who resigned last month, they are still on the list. It depends on obviously how often that list is updated. So those things you need to take into account as well to know that, okay, this list is very old. Even if it's old, what I'm studying, it's something that doesn't change that often, so I can still use the list. Or this list is old and what I'm studying is something that changes quite rapidly. I can't use this list because after a year or after 2 years or maybe even a month, when the list is not updated, it doesn't actually reflect the population. So you need to be aware of those things as to how up to date is the list that you are using, and be aware if it's not up to date, how much am I losing? And then you can cite those things as some of the limitations of your data. Then you need to check your list for duplicates, because you don't want to send 2 questionnaires to the same person. So clean it up if there are duplicates. And if you can, do some checks. As I said, check for elements which are no longer present in the population. For example, as I've said, if it's employees who are no longer in that department or that institution. If it's businesses which are no longer operational or which no longer meet the criteria of them being on that list. So those are the kind of things that you need to look out for. And you must just also check out that there are no elements that are on the frame which are not supposed to be there. So as I've said, in some instances, the logistics and the costs associated with creating it might not be feasible. So you might have to revise the definition of your population to fit the list that maybe is available, because you want to do the study and you want to use a list, but it's got limitations. So maybe you revise the definition to suit the data that you have. So maybe you make the population narrow instead of maybe looking at a province. Maybe the data at a provincial level is not reliable, but they tell you that certain districts are actually they actually update their data quite regularly. So maybe you exclude other areas where you know there are no regular updates and you stick to the ones where the lists are updated regularly. So as you work through their frame, you also have to make those decisions to say, maybe I have to narrow my population to one where I am sure that this list, at least it's it's credible. And then you need to be aware as well that as you narrow the list, even the population to which you can generalize is narrowed. So if you wanted to report, you do a study on Gauteng, and you find that a certain maybe Gauteng consists mostly of metros. So certain metros are more efficient in terms of updating the list of whatever. Then maybe you exclude one metro. So at the end, when you report, it will no longer be a reflection of Gauteng. You will say this metro was excluded. So your generalizations will also now be narrow, unless you can say that what was excluded is similar to another metro. So, you can take what you observed from the metro and actually infer to the metro that was excluded. Then you also have to consider alternative approaches. So in some cases, you do have a list, but as you go through it and you unpack it, you find that it's not really credible. It's better to consider alternative approaches. Obviously, alternative in this case is you go to a non-probability sampling scheme. So we're now going to move into the examples. I've asked Mr. Machila to share a data set with everyone so that we did do a demo in the first workshop, but because it was packed with everything, I rushed everything. So I'm going to repeat. I have an exercise, an Excel spreadsheet for you to be able to get a feel of, the simple things that you can do for yourself. Once you know the sample size that you need to select, you can actually go ahead and select the sample for yourself if you have the necessary skills. So the exercise is meant to give you a practical feel of how you can actually select your own sample. So in terms of simple random sampling, with this particular scheme, it's a probability sampling approach. With this one, every element of the frame has an equal probability of a selection. So if you know how people do it, if you don't have, you're not going to use like random numbers or Excel or a program, maybe people will number their population units, and then maybe you do a piece of paper, cut pieces of paper, one piece represents one population unit, and then you put them in the jar, and then you just take them out randomly like that, and then that would constitute your sample. All the things, the pieces that you put in the jar, they have an equal chance of being selected. They have an equal chance unless when you put them, certain ones were clustered in one area. But if you maybe mix to ensure that, everything is properly distributed, and you take one and another one, each one has got the same chance of being sampled. So that's what happens with a simple random sampling scheme. As I've said, you assign a number to each unit in the sampling scheme. It is suitable for homogeneous population because when you put those pieces together, we are assuming that they are all similar. They don't have, you find that this one is, for example, if let's say age is one of the variables of interest, you find that you have very old people and very young people, and it's just a mixture of age there. Then that the simple random sampling wouldn't be appropriate in that particular instance, because it is possible, because you are sampling randomly, it's possible that when you sample, you can sample mostly young people, or maybe sample mostly older people. because they have, so you don't have a control on to say, I want my sample to be balanced in terms of age. Because you just put them there, you can end up with a sample where mostly you have older people, young people, or middle-aged people. So it's not appropriate when your population is not homogeneous, meaning when it's heterogeneous. So a table of random numbers can be used. So we're gonna go to the exercise, which is an Excel exercise. So we have a scenario here. So suppose you want to determine the effects of watching TV on violent behavior of primary school learners. So you want to see, is there a relationship between the programs that the kids watch and violent behavior at primary school? So perhaps you are working at this particular school and you have observed that there is a high incident of violent behavior, and as part of trying to understand the behavior, maybe you're trying to link it to what the children are watching on TV. So you do a study like that. Obviously, you will add other variables, other supporting variables, but primarily you actually want to look at their pattern in terms of what do they watch on TV, how often, and is it related to the violent behavior that you are observing from your school. So suppose that the population size is 300, meaning that the learners in the school, all of them together, you have 300 of them. So for you to be able to determine the sample size, which is not the topic for today, you need to have the population size, and then you must know the level of precision to say, how precise should my estimates be? What error am I willing to accept? So in this particular case, we say we want a 5% level of precision. So suppose we don't know the level of violent behavior, but we can see that it is there and it's really it's really causing instability in the school. So in most cases, when you don't know, this particular example that I'm giving is when you are doing an incident where you are estimating an incident rate, to what extent that does that particular thing occur. So at the end, you'll be saying that from my study, I found that 76% of the learners do exhibit signs of violent behavior. So that would be the incident rate to say at this particular school, the level of violent behavior is around 70%. So if you don't know, sometimes as the researcher, as you are looking, you can say, I think it's about 50%, maybe 60. Whatever you say is what we will input when we estimate the sample size. If you say it's high, but you're really not sure, usually we stick with 50% to say we're working on 50% are exhibiting violent behavior. With 50%, it gives you the maximum sample size, so the biggest sample size with a 50%. If you go 30%, 20, anything below 50, you will get a smaller size than the one that you'd get with a 50%. Even if you go above 50, if you say it's very high, it's at 90%, the sample size will be lower. So with the scenario that I've given, I estimated my sample size to be 169. So for this particular case, I estimated the sample size to be 169. So we're going to go ahead now and select a simple random sample. I think I closed the file. So this is the sampling data that I've given to everyone. So here I have listed, I couldn't obviously use name. I identified the student. This is supposed to be the student number. So this is the coding that I used. In most cases, if you get data, you will have the correct.
Yeah, sorry to interject. I think maybe we can share your screen because we only see we only see the PowerPoint. Yeah.
Okay, it hasn't moved. Okay.
But yeah, maybe you can stop sharing and share the screen. But I've also shared a link on the chat for everyone to access the spreadsheet.
Okay, thank you, Tony. I think can you see it now?
Now it's visible. Thanks.
Thank you, Tony. So I have my 300 students here, as you can see. I'll go to the end. These are my students. I mean, I just make this data up. So I have my 300 students, and then I think there might be 301, I'm not sure. And then I've also assigned randomly, like in which grade are they in, and then I also assign some gender. So with a simple random sampling approach, I'm gonna do it in the other sheet where I said, because I want to keep my original data clean. So I'll go to that other sheet where I said simple random sampling. And then, so you need random numbers. You need to randomize when you are using a simple random sampling approach. I think it's already randomized, but let me correct it and sort. I think, yeah, because you got the same data set, I think you must also sort it as I'm sorting it. So you go to data. If you are following the example, you go to data. Once you go to data, the sort option pops up, and then you can say sort, and then you can say, okay, you want to expand the selection so that it covers, and then you can say my data has headers. You select there to say my data has headers, and then you select student ID, because I want to sort it by the student ID so that it goes back to the original. So my data will be back sorted again in the original. Yeah, it will be sorted again. So then I can start now to select my sample. So for you to randomize, you will use the rand function, which gives you random numbers. It gives you random numbers between 0 and 1. So I will go maybe and look for the rand function. So I'll just go down. I could say recently used because I've used it, but for the sake of everyone, I'm not sure if it's statistical. If it's statistical, you could have also gone to statistics, but we'll just look for it the long way. I could have typed it, but if you don't know it, this is how you look for it. You're looking for R. There we are at R. We're looking for rand. So this is the function that we are looking for. So you don't input anything. That's why into the function, if you know it, you can just say equals to rand, open bracket, close bracket. Otherwise, you can look for it through the function. Once you got it, you just say, okay, you don't input anything into the function. So it has given you a random number, but we want the random numbers for all our students, all the sampling units. So we will just press on the autofill so that it can compute random numbers. You can see the numbers, they are between 0 and 1. So it has computed. You can see this, the last one. It does have a random number. And this function is an active function. It remains active. It can just generate numbers. As you move, the number changes. When you come back, it's active. So for you to fix your sample, to ensure that your sample is fixed, it doesn't change each time, you can use the seed function. You can use the seed, or what you do is you copy this. These are the random numbers which you have. You copy them. So you select the column. You say highlight the column, and then you say copy. And then you can go to the next column and say right click, paste special. So once you have selected, you go to the next column, you right click, you say paste special. Then you get these options. We want to fix the values. So we don't want it to paste the formula. We want it to just paste the values. If it pastes the values, they will be fixed. So we select values. So we can see these ones. If you click here, there is no active formula. But if you click on the other one, the formula is active, meaning it will keep on computing, generating different random numbers. So we will work with this one. Which are your random numbers? So I'll just say rand number. So I've titled it random number. I'm not interested in this one. I can actually delete it, but I will just keep it. And then we will be working with this one. So now we have our random numbers. We want to select, how many do you want to select? 169. So what are we going to do? We will randomize. Because these numbers have got no order, they are just random. How we apply the randomization here is we sort. We sort by the random number. So you can select anywhere inside your data and go sort. It doesn't matter if you sort in ascending or descending order. And then you set my data has headers, and then you can sort by the random number. In this case, we are sorting from the smallest to the largest. So you go sort, and then this is what you have. You can see on the left, your data, there's a mixture now. The random numbers are sorted. It's from the smallest to the biggest. So it's from the smallest to the biggest. And then you can see there is randomized. Your elements have been mixed up. As you can see, they are no longer in that sequence that you had them. So going to 160, we're looking for 169. If we stick with the estimated sample, so this would be our sample. You can actually take it and paste it on another sheet to say sample, or you can highlight it, do what works for you. So this will be your sample. You can now just highlight it. So this is your sample. You have your 169 learners. So remember with the data set, I did say that this is an entire school, which is consisting of grade 1 up until grade 7. So here I sampled from the entire pool. So this would be my sample. If I followed a simple random sampling scheme, I'm sure your sample will not be the same as my sample because the random numbers which were generated will not be the same as the ones that I generated here. The range is the same, but in terms of the actual number, they are not the same. So your sample and our samples will be different. So this is how you would do a simple random sampling. I hope by just looking at this, some thoughts are coming to your mind. You are questioning some things in terms of the other variables, grade and gender. I hope some things are coming to your mind, which we will come to as we proceed. So this is how you would do your simple random sampling, and then you will continue and actually measure what you want to measure. Take this questionnaire, take the questionnaire and send it to these learners, or obviously the learners are under 18, so you will have to now get consent. The assumption is you already have approval to do the study, and then you can now get consent from the parents to give permission for the children to participate, or if the parents are also participating on their behalf, they can also indicate that if you are going to ask the parents in terms of their behavior, in terms of their patterns of watching TV, and then you will ask them about other violent related behaviors based on your expert knowledge as the researcher. So coming back to the presentation, I don't know, because I'm charging my laptop, but it still says low. Let me see, maybe something came out. Sorry about that. So yeah, this is how you select a simple random. So we had how many? We had 300 units, and then we are taking 169. So in terms of the probability of selection, it's 169 divided by 300. That would be the probability of selecting one learner. So we know the probability. The probability that a learner is included in the sample is 169 divided by 300. You must remember a probability will always be between 0 and 1. Those are some of the characteristics of a probability. It's between 0 and 1. It can be 0. If it's 0, it means that the probability of selecting or of that outcome occurring is 0. So it's not possible. If it's 1, as with the example that I gave with the business surveys, where the big enterprises are included with certainty, then their probability of selection is 1, because we already know that those big enterprises will be in the sample. So if that outcome, we know that it's going to happen with certainty, then its probability will be 1. So you, as you are doing your studies, I think one of the things, it helps to understand these things, because even when you get your results, you can see when things are not right, when your number is something that is bigger than 1, or when your number is negative, you know that you did something wrong. So some of these things are very helpful when you understand what you are working with, when you understand that a probability cannot be outside 0 and 1. Then you know when you're looking at your results, you know this is what I'm expecting. And if something you get something that is different to what you are expecting, you can already question what you have done. Unlike you just report and you are questioned later to say this is not possible. So moving on, we have systematic random sampling, where it is still a sampling scheme, but it is still a probability sampling approach, but our sampling is systematic, meaning that you can follow, there's a pattern as to how we are sampling. So if you do look at the diagram here, you will find that we are sampling maybe every 3rd person. But remember, with a probability, this is a probability sampling approach, is systematic random sampling. Systematic can also be done without it being a random sampling, which is what people do. For example, you would sit at the mall and you will say, I'm going to interview every 3rd person or every 4th person. That is systematic, but there is no randomness, and the randomness, you can only do it properly if you have a list. So I'll just explain how you do the systematic sampling. So you sort your population units, and then you select a random start. So there has to be randomness somewhere. In this approach, the randomness comes through the random start. Where you start to sample, your start is random. You don't decide and say, I'm going to start at 4. No, you compute a random number, and then that random number will be where you start. And then how do you proceed from the start? You now look at the interval to say, I'm going to select every kth element. K, how do you obtain K? You take your population size and you divide it by your sample size. So if I have 300 is my population size, and then I want 169, I divide it by 169. That is going to give me my interval to say, how do I skip to the next sampling unit? So that is how you would do your systematic random sampling. It has to have an element of randomness. If you are doing a systematic scheme, but there you are not, you haven't computed your random start, and you cannot actually report on the probability of selection. Remember, even with this one, the probability of selecting a particular sampling unit is known. When you are out there at the mall, you don't know what is the probability of selecting one unit because you don't have a frame. You cannot measure it and say the probability of selecting this 4th person will be this much. You can hear, we can already say the probability of selecting person number 1 or number 5 is this much, because here the only thing that is changing is the systematic. The probability of selecting each of the elements would still be 169 divided by 300. So I'm also going to go to the Excel sheet to show you how you implement this particular approach. So this was our simple random sampling. Now we can go to the systematic random sampling sheet to actually look at how you'd actually do that one. So in this particular instance, our data is properly sorted. We have our students here. They are sorted. The assumption is, I mean, the way they are sorted, the way they are sitting, or the way the student number is assigned, it's not based on certain attributes, because if it's based on certain attributes, then it can bias our sample. For example, if let's say in the class, let's suppose in the class, in one particular class, if let's say you were using, your numbering was based on where the learner sits in the class. In this case, my numbering is based on the learner ID, as in maybe their ID at school, not in class. So I'm giving you another example to explain something. Suppose your ID was based in the sitting position of the learner in class, and the way you let your learners sit in class, you mix them such that maybe you mix the ones who are disciplined. You ensure that maybe every 4th or every 3rd, there's a disciplined learner. You know, you make sure that in between the ones who are mischievous, you put the disciplined learner. So you sit them like that. That might be a problem for this scheme, because if you start with the, you might end up sampling the mischievous ones only, or the ones who are more disciplined. So your numbering needs to be, it shouldn't have a particular order in terms of certain traits. The traits have to be mixed within your list. So with this particular approach, you need to determine what is your skip, the interval. So from the formula that I showed there, you will say I have 300 sample elements, and then I want to select 169. So my skip will be around about 2. I will round it to 2. So I will start up until I stop once I have reached 169. So then, as we have said, that the start has to be random. So how do you get your random start? You will use the function rand between. So you go to function here. Once you say function, it gives you all the functions here. And then we go to we look for R again. So here is rand between. So I want a random number between what? Between 1 and 300, because I have 300. 300 units. Then I say, okay, it gave me a number. You can see the number that it gave me here. It's even changed. Now it's saying 216. I will go with 61 because it's at the top for me to demonstrate. So I will also copy this number and paste special so that I can fix it. I will know next time. Because if I don't fix it next time when I open the sheet, it's gonna give me 53. When I come back again, it's gonna give me another number. So it's gonna be difficult. So I can fix this one and then maybe also put a heading. This is my start. This is why I started. So we are starting at 61. 61 will be the first element, which is this one. So this will be the first learner to be sampled. I skip 2, 1, 2, then I will go to 64, will be the second learner. And then I will skip again. And then, and so on until I get to 169. If it's towards the end and you haven't sampled everyone, you are here, you will go back to the top, continue with the skip until you have sampled everyone. I hope this is clear. And then I will just go to the last, okay, not the last one that has a demo. The other ones do not have demos. So this is how you would execute a systematic sampling scheme. Yeah, the formula is there, and then that's how you implement it if you are using Excel. And then the other one is stratified random sampling. So you saw with the data that I have used there, I hope as you were doing it, especially when we're doing the simple random sampling, at this point you can see its limitations. As you saw there, that we have grade 1 up until grade 7 learners. And with regards to this thing that we are studying, you do not expect their behavior to be the same. Starting with the independent variables, do you expect the pattern of watching TV to be the same? I mean, if you a grade 1, you might find that the parents are more present, they limit, you know, and also, I mean, a grade 1, maybe they cannot sleep late naturally. So some of the things which maybe are only accessible late, they can only access them late. All this also depends on the population. I mean, if your population, your school is in the urban areas where there is access to a lot of things, the parents have access, you will find that the dynamics will change, because with the example, maybe the school being maybe in a rural area you will find that mostly access to these things is through TV. But if you change the environment, you'll find that access will, in addition to TV, you will have your tablet, you will have the phone. So you will find that now the mode of access to this kind of the programs that you want to investigate, it's now bigger. But if you limit it maybe to a school in a rural area, you probably maybe just focus on television, because most people, their access is through television. Even though their parents might have cell phones, you might find that the learners don't have cell phones. If they do, they don't really have access to much data for them to really, yeah. So there are all those dynamics which you need to take into account as you are deciding on your study. So as you saw, we have learners who are in grade 1, grade 2, grade 3, grade 4. As I've said, you don't really expect them to be the same. So they are not homogeneous, these learners. I mean, the ones who are in grade 7s, you will find that they even know when maybe they watch, even when the parents are sleeping, they can sneak out and go watch TV, or, all those things. So there are all those things which are coming into play. Therefore, it makes that particular group not to be homogeneous. So when you do a simple random sampling, you are not really, it's not efficient, because you're not ensuring that you cover all the groups. As I've said, you might find that most of your learners are actually coming from grade 1, grade 2, grade 3, where the other grades are underrepresented. But when you know that your population is not homogeneous, and for example, the other variable that I've put there is gender, you might also find that gender also comes into play. I mean, times have changed, but in our days, there was a difference between what girls used to watch and what boys used to watch. So you would find that boys would be more, would be the ones who are watching more of the violent, or the things which have violence. You would find that they are more appealing to boys. That's my own observation. So I've put gender there in case gender is a variable there. We assume in this particular case it's a variable that can come into play, and then you say there is no homogeneity. Then if I sample randomly without taking into account the other variables which are now bringing differences in my sample, in my population, then my sample will not be efficient. Then what it takes us to is stratified random sampling. Because I know that my population is not homogeneous, then what am I going to do? I need to divide my population into mutually exclusive, non-overlapping groups, which are called strata. So I take my sample and I group it. So in that particular instance, I have two variables. So I will group by grade. You can take it further and say grade 1 and grade 2 are similar. So maybe grade 1, grade 2, I will put them in one group, or grade 1, grade 2, grade 3, I can put them in one group because I have, based on my knowledge of the subject, they are similar. And then the other grades, I group them also accordingly based on my knowledge, and so forth. In my example, my grouping is grade, so meaning that each grade is a group. And then I can also apply the gender to say it's grade, and then I also group by gender. That would be my stratification. So I know that in one stratum, I have my units are homogeneous. So in one stratum, my units are homogeneous. When I go to the next, it's different to the previous one. But within one group, there is a homogeneity. And I will be sampling from the group. I will no longer be sampling across. I will be sampling within these groups that I have created to make my sample to be efficient, to ensure that Sometimes we stratify because we want the sample to be representative properly, because we know those differences. Sometimes we know those differences and we actually want to compare those groups, and you want to make sure that you have enough sample in those groups to be able to do a statistical comparison. Because if you don't have enough sample in the groups, where you find that some groups you have enough sample, but the other groups you don't have sample, you might not be able to do your statistical comparisons. So there are two reasons. Sometimes we just stratify just to make sure that the sample is representative, but we don't really want to compare. We just want to make sure that it's representative. I have enough people in grade 1, in grade 2, in grade 4, and so forth and so forth. In other cases, over and above ensuring that my sample is representative, I'm also stratifying to ensure that I have enough sample. So even how I'm going to allocate the sample to the group will differ. So as I have said, you see with the picture, we create groups, and then you sample from the groups. From the groups, you can sample using simple random sampling. You can also sample using systematic sampling. With the example that I will follow, we will be using simple random sampling. So we'll go back to the Excel to do a demo of how you'd actually implement that particular scheme. And then after this, we can take a break, and then we can look at questions. So this is our list again. Here we have it. I go to that sheet that I labeled stratified random sampling. So with this one, you need to know how many elements do you have within each group. So for simplicity, I'm going to create my groups using grade. So I'm just going to do a pivot table. So I'm doing it with you so that you can actually be able to do it for yourself without having to go count. So I'm going to do a pivot table for me to count how many grade 1 learners I have, how many grade 2 learners I have, and so on and so on. If I wanted to add gender, I could also add that. So we will insert a pivot table. So we can say insert there. Once we say insert, we get the pivot table option there. We can select it. I think I was outside the data. So now I can say select. So you have to be inside, your cursor has to be inside the data, somewhere inside the data. So it has selected my data. As you can see, I want to put it in a new worksheet. I will copy it from there. So I will say new worksheet. Then it takes me here. So I want to do by grade. I can also maybe do by gender, but I think I will end up, and then I want the students. I want the students. I want to count the students. So you can see the summary. This is the summary that we want, which we will use. We have, yeah, we've got one extra student, which I put by mistake. It's fine. I don't think it will make much of it. So I'll copy this to that sheet. Yeah, I put paste. I just put paste there so that I can see. So we can see that we've got how many? 25 female grade 1 learners, 20 male, 20 boys. We've got 27 girls in grade 2. We've got 21 boys in grade 2, and so on and so on. And you can see that in most cases, we've got more females than the males, and also the grades, the classes are not really equal. I mean, you might find that this is the total. So maybe Grade 1 has got 2 classes. Grade 2 also has 2 classes. So this is just the total. So the totals are not actually, so the size of these grades also is not the same. So I have 2 options, as I've said. One option is just to create my groups based on grade. If I create them based on grade, I have 7 groups because I have got 7 grades. But if I use a gender as well, then I'm going to have 7 by 2. So one option is this. This is one option. And then this will be the total. So this is one option. This will be your strata. This will be the size. This is the size of each. The other option is will be I'm going to have grade 1 female. These are the possible groups that I will have. And then similarly, the other group for the males, for the boys. So these are the possibilities. So if I go with this one, the size, this will be the size for the boys, or for the girls rather. Then this will be the size for the, these are just totals. So in this case, I've got how many? 12. 14, supposed to be 14. Yeah, I have 14. So I will have 14, the strata. There will be 14 all in all. Here, I will have 7. So if I stratify by both of them, this is what I will be having. So I know that I want, how many do I want? I want 167 and I have 301. I already know the sample size, which I started with at the beginning, that we want 16. It's saying 167. I think there's something that was not counted properly, but I will go with 169. Yeah, it was supposed to be 169. I don't know why it's giving me 167. I don't know what I did wrong, but it's giving me, no, it's correct. It's giving me 301. It's correct. 301 is my population. I haven't done the sampling as well. So 301 is my population. Remember, I put an extra person there by mistake. So I'm at 301. I have 134 boys, 167 girls. So in total, I have 301. Then this is the size. So if I'm going to go with the one with 14 groups, then we need to now allocate the sample. How many am I going to take from this group? From grade 1 females. Out of 25, how many am I taking? Out of grade 2 females, how many am I taking? How out of the other group, how? And then similarly with the males, the boys, How many am I taking from grade 1 out of 20? So you need to allocate the sample. The total is 169. I need to now distribute it here. So there are several ways. The one that is that we frequently use will be we do proportional to size. So I will say that, so I will come here and say that this one, how much does it contribute to the population? How much does this group contribute to the population? So I take 25 and I divide it by 300. So this is the share. I will divide each one by 300. Can I just do this? So you can see this one is proportional to size, meaning that the big groups will get the biggest chunk of this 169. The small ones will get the smallest chunk. You see, this is 0.1, it's 10%. This group is going to get 10% of 169. And then the other ones will get their 0.07 and so on and so on. You can insert another column. Maybe I must just say this. Maybe this is NI, the sample for these groups, and then I will just say here share because I didn't put I don't want to put the formulas. And then now I want to distribute my sample. So you have a share of this much from 169, which is the total. So this is your share as a group. You contribute this much to the population, and then you will get that much share on the sample. So here I will take 14 and so on. Where is that one with 30%? This one, it got more. And then you can round it. Whether you, most of the cases will round it up, which will make your sample to be slightly bigger by some units, 2 units, 3 units, that is okay. So I will round it. I will round it up. Okay, I must also say how many digits. I don't want. Oh. Okay. Yeah, so I'm rounding it up. Or I think I would rather take this. Yeah, there are several options. I think I'll take this one. This will make it smaller, but it's fine. So this is what I will end up with. If I use if I use the integer, I take the integer. I'm short by some units. So I can also go back and change and make it and make sure that this becomes 17. So I can also, I do also have that option of doing that. So once you have the size here, what you can do is you can now go and select. So what does it mean? It means you must group your elements accordingly like this. You must sort them in this particular way so that you can be able to do the random numbers and then sample within. So I'll use I'll use two examples. I think I'm gonna copy it again to a different sheet, because when I sort, it's gonna affect my table there. So I'll copy it to a new sheet and I will sort it before I bring the other things. So to sort, you can go data, sort. So I want to sort by grade first. And then I want to sort by, I add another level. I want to sort by gender. So this is how it is. My first group, you can see I have my grade 1 girls. Here they are. Then I will have my grade 1 boys. Here they are. So it has grouped them like that. So if we go back here to where we were, and if we take this, for the boys, for the females, we are taking 14. And then for the males, we are taking 11, 14, 11. So we can come back here and we do our random numbers so that we can randomize. So we can do that. We can do for everything the random numbers. But we know here we are taking how many? I forgot, 14. So this will be your sample. These are your 14 from that group. And then you can go to the next one, your other group. Unfortunately, you have to be, you must copy and paste, because when I sort by the random number, it's messing up. I actually didn't sort by the random number. I missed the part of sorting by the random number. So you can actually take this. Best thing would have been to come here. Let me not sort. I think the best is to copy it before you sort. So I'm going to undo the sorting. I'll just sort again by the student ID. Sorry about that. Okay, it didn't sort properly. Sort student ID. Yes, so I'm back to my, I think it's better to do this. Copy. Sort again by the add now, and then sort by gender, sort by grade. Get your data back in order. Yeah, here I have it. Then copy the different groups to the different sheets. So you will have a sheet for each group. So I'll just copy the females, and then I can copy them to, then you can rename it and say grade 1. These are your females from grade 1. Then you are sorted now. So This is everyone from grade 1 who is a girl. Then I can now do my selection. The random numbers are already there. I don't have to regenerate them again. So all I can do is just paste, copy them, and make them fixed, as we did in the other examples. Paste special, values, like that. And then we can sort by random. So we can come here and then we can sort. Can say my data has headers, and then we are sorting by random. And then now we have our sample, our random sample. I'm supposed to be taking 14. So this will be the 14. So this will be your sample for this group. And then you go to the next group, you copy it the way I've done it, and then you paste it, and then you select the sample, and so on and so on. So you will see also, because the weight is not the same, based on here, their weights are not the same. Their inclusion probability will not be the same. Within a stratum, they have the same probability. Within here, they have the same probability. But we have two levels now. We had the stratum, and then we have here, they have the same probability. But because the group which they belong to they don't have the same weight, the overall probability at the end of them being in the sample, their probability of being in this group is the same, but their probability of being in the sample is not equal. And then you do have other options where you don't want, here I'm doing probability proportional to size. I'm allocating the sample proportional to size. In other cases, you want it to be equal, meaning that it doesn't matter. I will be taking the same amount, so their share will be equal. If I have 14 groups like this, their share will be the same. In other cases, you find that some of the groups are small, but because you want to compare, you need to have enough sample in those groups. So you oversample from those groups. So it's a small group, and if you go with probability proportional to size, you know you're going to come back with a small sample, which will not allow you, and it's still a sample, remember, it still has to go out, and you still have to get people to respond, and you're still going to get non-response, which will be, it's going to reduce it even more. So when you have small groups which you want to compare, you want to use them for comparison in your analysis, then you end up not doing a probability proportional to size, the allocation, but some groups you give them more, and others you give them less, because the other groups by default will give you a big sample because they are big, but you want those small groups also to have enough numbers for you to do comparisons, so you will change the approach. So your analysis, what you intend to do with your data, also comes in when you are selecting an approach, especially when it comes to stratification. It will come in here in terms of now, how do you allocate the sample to the different groups. So there are many approaches. There is like square root, Neyman. So you can go and look at those approaches. I think you understand the general idea. Now you need to understand the different methods of allocation and what are the advantages of this one and the other one. If you just want your sample to be representative, then this one will work. So we've covered this one, which was stratified. We did see that if your population is not homogeneous, meaning that there are differences in terms, the variables, they differ, in terms of what you want to, the differences have to be related to what you want to measure. If they are not related to what you want to measure, it's not a problem. So it has to be homogeneous in relation to your variables of interest. As we saw with the example that I gave, we used grade and we said that grade might actually have an effect on in terms of the pattern of how much TV they are exposed to. You might find that the older kids are exposed to more television and actually more of these programs that have that are not appropriate as compared to the younger learners. So grade would be introducing differences there. And as the example that I gave in terms of boys and girls, you do find sometimes that the boys are the ones who are more likely to be drawn to certain kind of programs as compared to the girls. So that variable can introduce a variability there. So to ensure that your sample is efficient, you move away from doing a simple random sampling, and then you now stratify, meaning that you group your sampling units, your population units rather, into homogeneous groups. So you'll have to identify those variables which you are going to group your variable, your population by. And then once you have done your grouping, then you sample within, you estimate the sample size. We already know the sample size for the study, and then you allocate it. You allocate your sample size to the different groups. With the int that I use, it's giving you an underestimate. Then you can use something that will maybe round which will give you an overestimate of your sample. Maybe you round it up. So when you've got 11.5, you round it to 12. So rather maybe use a function like that would achieve that. So moving on to another type of a probability sampling scheme, we have cluster sampling. So with cluster sampling, you divide your population into clusters. So it's similar to the stratified sampling that we've just done. The difference here is that your clusters, within the cluster, you don't want homogeneity, you want heterogeneity. With the stratified random sampling that we did, we're grouping our variables in terms of homogeneity. They must be similar. The elements which are in one group have to be similar, so that you know that when you sample randomly within there, your sample is efficient. With this one, you usually do it when the clusters are naturally occurring on the ground. Usually, it's usually done when we are doing something that it has a geographic listing, and then you can select the clusters on the ground or geographically, and the cluster that you select has to be representative of the entire population. So with cluster sampling, instead of going into a particular area and selecting a random sample, you take that particular area and you group it, you form clusters. So the clusters will depend on the sample size that you want, because one cluster will represent the entire population. So your clusters have to be big enough such that if you select one cluster, that particular cluster has got enough units to represent the entire population. As I've said, it's usually done when there is geographic locations. The clustering is like a geographic related. So the example that I would give, for example, the example that I do use is like when we talk, and sometimes it's also because of the difficulty of implementing a simple random sampling in maybe a particular case. So the example of your informal settlements in South Africa, like today I have a picture. So when you want to do a study, if this was an informal settlement here, you can't do random sampling here because with our informal settlements, we already know that there is no proper structure in terms of formal roads. There you might have several formal roads, but once you get inside the settlement, you find that most of the roads are dead roads, and you find that so you don't have street names and you don't have house numbers. So even if you want to do a systematic scheme, you don't have a proper numbering that you would maybe use in an urban area. Here, the houses are similar. Even when you create a list, when you come back next time, you find that that house, because when you describe it, you can't describe it using the house number. In urban areas, you know this house by the house number, and when you come back, you look for the house number. So your listing is stable. It remains like that. Even if they change the house, they change it from a single story to a double story, you'll still be able to locate that particular dwelling unit because it will be the same house number. When you come to informal settlements like this and you want to do a study here, and when you have to do a listing, you have to describe a structure using the way it appears. To say this is a pink shack with a green gate. And so you describe all the features that you are seeing there to describe that particular shack so that you can distinguish it from the next shack. But you might find that when you come back, that pink that you described is no longer there. All the features that you used to describe, they are no longer there. So your list becomes unreliable. So what is usually done is you will come to this place. This obviously you must be having a map and all those things. You find that maybe the municipality does have the map. And then you divide this place into clusters. So if you want to have 50 households here or 50 dwelling units here, then you will go into this area and you use the dead roots, the dead parts here, and some landmarks. Maybe there's a tuck shop, there's a church. You to demarcate, to form your clusters. So to say from this corner where we have this church or where we have this shop, going straight up until this corner where it is this what, and then I turn right, then you say up until here, it's one cluster. So you describe this, what constitutes a cluster using the features that are there on the ground. And then you demarcate. And then at the end, you have a list of, even if the structures change within the clusters, but your description of the coverage in terms of what constitutes a cluster is most likely to remain, because these dead roads are used as they're used frequently. That's what we use to move around. And the tuck shops, they are usually there for long, and the churches and the other features that you would have used, maybe a crèche or something. You try to find features when you create these clusters. And then once you have the clusters, you will select one cluster. Then when you come to do your study, everyone who's in that cluster will form part of your sample. So this is one area where you would apply a cluster sampling, where you demarcate, you separate. You can see here in the picture here, you create clusters. Your clusters have to represent the entire area. You don't want clusters that are homogeneous, because if they are homogeneous, our sample is biased. It means that if my cluster, it will have certain attributes, only certain attributes which do not represent the other people. So the cluster has to be diverse such that it represents everyone, because I'm not going to go to other houses. From this cluster, I will make inferences about the entire area. Yeah, so for example, if you cannot, even sometimes when you cannot have complete lists, but you've got something to work with, then you can cluster and select a cluster. But you can't do a cluster when the list is on paper. It has to be kind of geographically linked. So here is an exercise for you to think about more about the cluster sampling. Suppose you want to determine the health status of children between 2 and 5 years. So suppose you want to determine the health status of children between 2 and 5 years. How can you go about implementing a cluster sampling design? So this is what you want to achieve in your study. So, for instance, I mean, here, the questions that I throw up, they are not really confined. So even in your thinking, you can really go as wild as you can. So one solution would be to select villages within a region. So if I know that all my villages, I know that in this village, I have different attributes. And all my villages, what I find in this village, I will find in the next village. Then I can select maybe 2 villages, depending on the size of the villages and what my sample size is. And then I only go to those villages to go and do my study. Everyone who is in that village, then I will be able to interview the parents to assess that all the children in those selected villages, and those selected villages will represent the entire area that I'm interested in. Another option would be to select early childhood development centers and interview parents and assess all the children in the selected centers. What would be the limitations of the second approach? I'm gonna pause and wait to hear your responses. What would be challenges if I opt for the second approach? What are some of the things that I might have to think about? I'll wait for 1 or 2 responses. You can share your thoughts because what you are thinking is helping us to unpack our understanding of what we are going through. So you can share your thoughts. What you are sharing is going to help all of us. So I'm eagerly waiting for some of your thoughts. Tony, is there anything coming?
Nothing yet.
Okay, I'll give you 1 more minute. I mean, you can just share your thoughts and then we will unpack them and see. And maybe you'll also, make us aware to, I have a thought, but you probably, when you share your thoughts, you might even make me aware to some things that I had not actually thought about. So please do share your thoughts. Okay, nothing is coming. Tony? Anything, Tony?
Nothing yet so far, Ms. Masondo.
Thank you, Samu. So, for example, you were saying something, Tony?
Nothing still. Someone can anything from my side?
Okay.
No, there's nothing.
Okay, thank you, colleagues. So for example, with this second one, we are looking at 2 children between 2 and 5 years. So if you decide to select, what about the children who are not in those centers? Are you saying you're going to exclude them? Yeah, so those are some of the things that you have to think about. You might, if you know, in terms of the participation rate, if you know that in that particular area where you want to do your study, most children in that age group are in these centers, then you know that your coverage will be good. But if you know, like in South Africa, I mean, children who are 2 years, mostly they're at home unless there is no one to look after them, because yeah, these things we pay for, they are not free. So there will be, if you go that route, you must know that you are excluding. I mean, even children who are 5 years old, you do find them at home because the families cannot afford to send them to these facilities. Sometimes they only go when they really have to go to grade R, where they can go to a school where the school is a non-fee paying school, and they don't have to think about those monthly costs. So yeah, you have to think about that when I take an approach, am I including everyone that I would like to include, or is this approach going to exclude some of my potential or some of the population, and to what extent is it excluded? If it's to a small degree, you can probably proceed with the approach. If you are not covering, your coverage is poor, then you have to change the approach to something that will make your results or your sample to be more representative. Then the last one under this theme is a multi-stage sampling. So with multi-stage sampling, it will incorporate all the elements that we have learned. It's just that you don't sample once. You have different levels of selection, whereby, for example, you will find that you select, for example, with the example that we used, we had 14 groups that we had created, and we used all the groups. In other cases, you find that we create our strata, and then from within the group, we select, we don't use all of them. And then the next level, we select our sampling units. In some cases, let's say, for example, you are looking at school children, then maybe your first level of selection will be schools. And then within the schools, you will select the learners. So within the schools, maybe you will use a systematic approach, and then you will have another approach, maybe random sampling or still systematic, to select the schools. So the schools are also, you have a population of schools. So maybe even the population of schools, you group it based on attributes, similarities, so that you've got homogeneous groups, and then you select schools. And then from the schools, you go to the next level, you select. So that would be a multi-stage. In this case, it's a two-stage. First level, we are selecting schools. Second levels, we are selecting the actual units we are interested in, which are our learners.
Thanks, Masondo. The questions came in later on, but there are two. So the answers was you might only meet parents with sick children, and the other one might only meet parents that are concerned about their health.
Okay, thank you for those. Yeah, maybe I didn't give proper context, because the early childhood development centers are like preschools where the kids go to play and learn age appropriate things. So those centers, they are not necessarily health centers, but they are education centers where the kids, yeah, it's like your crèche or your preschool, but to cater for that particular age group. Thank you so much for the comments. Thank you for the comments. So this is the last one under probability sampling. Now we move to non-probability sampling. So with non-probability sampling, we have said at the beginning, we don't need a frame. So one thing we must move with when we proceed, we don't need a frame. So we have several schemes under this, several approaches under this scheme. The first one would be volunteer sampling, where your participants volunteer. Remember, these things, you will still have your sample size. So for example, if I go back to my example with me wanting to look at look at learners and look at the behavior, the patterns in terms of how much TV and what they're exposed to, and how it's related to violent behavior that they are actually showing. You can, for example, use a non-probability approach, which means that you're not going to go, remember, because we are dealing with children, you might get consent from the parents and from the school, and then the children volunteer to participate in your study. The parents have given you permission, and then you can ask them questions. The children who don't want to, you go to the school, and then you try to get your 169 by using that approach. So you're not in control, you don't know. The children who are participating, are they the ones who have got these patterns, don't have these patterns? Are they the ones who are timid, and they are the ones who cannot really say no to anything? And if it doesn't affect your other variables, it's not a problem. But if you find that the children that you are willing to participate are have certain attributes which can potentially influence your study, but you are not aware of them, since you're not controlling, you're not in control, they're just coming, then your sample will be biased in that way. So the example is customer satisfaction surveys, whereby I go to the mall. When I come back, each time I come back, I will get a welcome email to say, please rate our service. And then I will decide whether I rate the service. If I had a very, very good experience personally, sometimes I do rate it. If I had so usually I rate it when my experience was on the extreme. It must have been very good or very bad. If it's normal, I don't rate. But if it's on the extreme, I do rate. Because when it's not good, obviously I want to express that I was not happy with 1, 2, 3, 4, 5. And there have been instances where I was called actually as a follow-up by that particular company to say this was my rating, why? And then they made a follow-up, and yeah, my dissatisfaction was resolved. And obviously when I'm happy, they don't follow up. They're just happy that I'm happy. So this would be an example of volunteer sampling. And then another one is convenient sampling, which is used. This one is the one that is commonly used. Remember, I mean, we have to do research. So you do research within what is available to you. Sometimes other things are available, but because we are not aware, we usually opt for convenient sampling. And because we are not aware of the benefits of probability sampling and how you can actually implement it, usually people opt for convenient sampling because it's easy. Even though they actually had the option, they frame everything to do probability sampling, but because of not having understanding and not having the confidence, usually we end up we gravitate to convenient sampling. But I hope with, the lessons that we are taking from the workshops, we will be able to not be moved to convenient sampling because it's easy, but we will choose it because it's what is available for our study. We don't have other options. So with this one, obviously, if you want to look at satisfaction with library services, and then you will go on campus, and then in most cases you will sometimes maybe even go towards the library, even worse, and distribute your questionnaire there to the students who are entering and exiting the library. What would be a problem with actually is there anything wrong with the approach of actually sourcing the students from the library or around the library area? Would this be the best approach, or can it introduce, what can this introduce, this approach? I'll also pause for a minute to get your thoughts. Because we have to interrogate what we are doing and be aware, even though it's not a probability sampling approach, you still have to put some controls in place if you can. So you need to be aware, this is what I'm exposing myself to. This is what will happen if I approach it this particular way. So what would be or maybe a potential problem with this approach? Guys, please say something. Share your thoughts there on the chat. I'm waiting. Nothing, Tony.
Yeah, one is saying bias. One is saying bias.
Yes, bias. Because I mean, obviously, thank you, Tony. Thank you also for the comment. Already with the convenient sampling, the bias, it's just open to bias. But now you actually going to distribute your questionnaire around the library area, you are actually introducing more bias, because the people who maybe are using the library may be of maybe who are using the library more often, maybe they have certain attributes. Maybe, for example, it's students who don't have, I mean, if we take a residential university, maybe it's students who don't have the prescribed books. So already they have a certain socio-demographic profile. So maybe most of the students you are going to get there, maybe they have different views. The other ones will tell you, yes, I'm happy. The other ones will tell you, I'm not happy. So you will get diverse responses. But you might find that there is an underlying factor there where maybe most of the students there, as I've said, are students who don't have prescribed textbooks. So they are frequently using the library to access the textbooks for their studies, because they cannot afford to buy the books. I mean, it's just an example that I'm giving. So you find that your sample actually constitutes of people with a certain demographic or economic class. So it's already, it doesn't represent, because the university is not made up of only that class. The university population, in terms of students, it's got different classes of students, but you, with your approach, you only captured a particular class, and you are not even aware. When you present, you'll present them as if they actually represent anyone, whereas there is a class that is hidden there, and your class, your results actually just represent a particular class. So those are some of the things that you need to be aware of and try to control. So maybe you have to try different days, different locations of the university. You know, if the university has got expensive restaurants and the other more affordable, so try and collect data, even if it's about the library. Try to, you know, different zones where you think you'll get diverse groups of students in terms of, yeah, some of the background. I think the example is the same as when we go to the malls. The time that you go to the mall can introduce more bias to an already biased approach, where if you go in the morning, you will find a certain group of people. So your sample is no longer representative, because you're only going to get a certain group of people. So I see also with people who do tourism studies, they will go to the attractions, and then they will be distributing surveys about their experience of that particular place. So you find that a person will go once, and then if you say I mean, you can obviously provide context. So if you go on a Saturday, then you must know that your sample is representing the people who go on Saturdays. It's not representing other people who go whenever they want to go. And also the time. And also the season sometimes can also affect the people you attract. So you need to think about the context of your study and unpack it and say, okay, I'm going to attract this particular group. I'm happy with it. I'm not happy with it. This is how I'm going to intervene. I will maybe probably go every day because I want to target everyone. Those who go during the week and those who go on weekends, I want to target all of them. And maybe I want to separate them because maybe on weekends, the place differs. They offer more options or during the week. So there are all those dynamics that you have to factor in. And then there's also purposive sampling where me as a researcher, I will choose a sample based on what I think would be appropriate for the study. So usually you use it when there's a restricted number of people in the population who have those the qualities that you are interested in. So it doesn't help to go to everyone. You are going to this group because you know they have what you want. So let's say you want to look at really a particular religious belief system, and you know this is where it's practiced. So you use your knowledge to say, I will just focus here. And then we also have snowballing, where I have access to one respondent. I know one person, and then I will use that person to recruit other people. So it's very difficult to find respondents. And I think now it's being used quite a lot with COVID. I mean, it's usually used when, before COVID, we were using it when we had, those cases where it's difficult to find participants. But now it's being used because we can't access participants. So people, they're using Facebook to get participants to say, I will send to my friends, I'm doing a study, and I will send the invitation to the people who are in my network, and they can share with, they can share the link and everything about the study with the people they know. So it's not really a snowballing per se because they won't, the people might not respond, but yeah, it does have that element where I get you and you take me to the next person. I think it's not the Facebook approach. I think it's actually not snowballing. It's just creating publicity for you because those people will not necessarily respond. But with snowballing, I ask you, you respond, and you take me to the next person to say, I know another mother who has a child with this rare disease. And then that mother says, I also know someone in our group. We have a group, then, and so on until you reach your sample size. Probably your sample will not be long, will not be large, because the population itself is small. And then we also have quota sampling. So quota sampling is similar to stratified simple random sampling, as we saw, where as much as my approach is a non-probability sampling approach, but I'm also aware that my population is not homogeneous. So I'm not using a probability sampling scheme, but I know that my population is not homogeneous. So because I have that knowledge, and I also have totals of subgroups, so what I will do is I will divide my population into subgroups. So even if, for example, I'm targeting students and I'm doing a library satisfaction, service satisfaction study, what I will do, I will say, okay, I'm looking at students. These are the different students which we have in the university. So maybe I will separate the ones who live on campus. Maybe the residence is on campus, so they're in close proximity to the library. I will also maybe use the level to say undergraduate, master's, the postgraduate diploma. Maybe use that also to group them to say their behavior with regards to the use of the library. I know that it differs, so I will also apply the quotas to ensure that my sample represents everyone in terms of the quota. If I know that 20% of the university is made up of PhD students, I will ensure that my sample has got 20% PhD students. And then if 50% is undergraduate, then I will make sure that my sample is 50% undergraduate. Then the 30%, I will share it, maybe 10%, maybe it's for honors and postgraduate diploma. And then maybe the other 15%, the 20% is for master students. So I will apply those quotas. Even when I do my non-probability sampling, I will ensure that my sample meets those quotas so that I can say that I've covered all the groups within my population. Yeah, so even with your allocation, because you have the sample size, it's 167, the sample size, and then you will say, okay, I'm going to allocate it. 50% of that sample will go to undergraduate students, that's a half. 20% will go to the PhD, and then the honors and the master students will also have their share, so that my sample is represents all groups. Or I will say that I want equal from, so I divide that 167 by the 4 groups and they equally share it. So that is also, it's not going to be proportional, it will be non-proportional. When it's proportional, it will be the same as the example that I used, where we used the size to say the measure of size. How big is the size? And then the bigger the size, the more share you're going to get. And then once you have the groups, you still select within the groups using a non-probability sampling approach. So wrapping up, then we have sampling errors that we need to be aware of. Obviously, with your non-probability sampling schemes, there will be more of these errors. Systematic, within the sampling errors, we have those that are systematic and those that are random. So the systematic ones, they are introduced by the researcher. So you might introduce them by not being aware of certain things. For example, the example that I used with the library, where you sit at the library and you target people, learners who are going in and out, and then the sample is biased because you didn't factor in that there could be an underlying variable there. So you, as the researcher, in your approach, you introduced bias. Or you actually send your questionnaire to everyone, but only a certain students with certain attributes respond to your study. So that one is just introduced by the sampling scheme. You don't really have control over, because the people, when they respond, it's their choice whether to participate in your study or not to participate. So mostly the sample will not really truly represent the population of interest. So, and the sample sometimes is not selected properly, because as I say, sometimes you do have an opportunity to use a probability sampling scheme, but you go for the easier one. Or even in your, as I said, when you don't have, you can't use a probability approach, but you don't apply your mind when you're doing your convenience sampling to put controls in place. So you are introducing the errors, they are systematic. With random error, they are by chance, they are just random. There will always be error. I mean, because we are not sitting together, if we were sitting together, I would have been able to actually, maybe if there was age there or there was weight associated to those children, those grade 1 to 7 learners, maybe we could compute age. Because we are all getting different samples, because the random numbers that we are getting are not the same, we will not have the same average. You will have a different average, I'll have a different, my average might be closer to the real one, to the population average. Yours might be slightly far. So there will be that the errors that are introduced by the fact that we are sampling, but they are not systematic, they are random. So as I'm saying here, the estimates will vary from sample to sample, and the error is random. But this error, we can describe it. And usually when we make inferences, we take it into account. You will hear, we will report the confidence interval. When we report, this is the mean, and this is the confidence interval. If you read reports, for example, some of the reports from Statistics South Africa, you will find if you go to the technical notes, they will tell you about variation. They will report CVs there, coefficient of variation, is to give you the reader to say, this is our data, this is our results, this is how we did the study, this is the sampling approach we followed, this is how we did everything. Associated to these estimates that we are reporting, this is the coefficient of variation. So they will report the error in different forms. And you as a reader, you are able to say, the error is high, not high, but we are able to report it and quantify it. And when it's very high, we're able to go back and maybe try and see. And if the results are reported, you can caution the reader. But everything is quantified, is there for the reader to make a decision to say, these things are reliable, not reliable. But with when you are doing convenient sampling, you can't report those things. So we just have to believe that everything is well. But with the other one, you can make a decision. You can actually make a determination to say, with this confidence interval that is being reported, no, the confidence, the interval is too wide. No, I cannot use this, or it's just, yeah, they are not reliable, but you can make a determination with when you are using a random sampling, a probability sampling. So the errors are random, they are not systematic. So in summary, these are the advantages and the disadvantages. I think I've highlighted them as I was going through the presentation, that a probability sampling approach, you reduce the chance of systematic error and the chance of bias. You can produce a better representative sample, and then you know what you can generalize to. Obviously, it requires more effort, more knowledge, more time, and maybe it's also expensive because you need a list. Sometimes you have to create it. You are the one who have to create it, and that is going to take you resources to actually create that list. Or if there is a list that is existing, maybe you want to update it. Maybe it's not up to date. You say, I want to go the approach, but I need to update it. So there will be money in you verifying the list and calling other people, trying to make it more up to date. For example, if it's a list of a physical place, you can actually go there, or you can have field workers go there and take the list and compare it with what is on the ground. And then where there are differences, they can update it before you sample. Your list is up to date. So that would have obviously a cost implication there and a time implication there. And then non-probability sampling, it's you don't really need much effort, less time, less costly, but it does have those disadvantages of, you have those systematic errors, the bias, and you can never be really sure that your sample is representative. When you select it, when you think about it and conceptualize it, you might have a proper conceptualization, but when you implement, it can just take its own course, where you just have people who favor a particular brand respond to the study, and the other ones, they don't participate. So coming back to generalization, that so there are so many arguments with non-probability sample. So some people will say, even if I take, for example, the example that we used when we use students, we use convenient sampling, and we go on campus. Some people will say that the people who will respond the students who respond, I can safely say that they are not different from the general student population. So even when you are using samples of non-human participants with maybe animals, they will say that all the dogs from the same strain, if I have dogs from the same strain, they will represent all the other dogs from that particular strain. So there might be a level of correctness there. I mean, and the thing is, we cannot really quantify it. We cannot prove it. There is no evidence of that. So we just have to go with, that's what you believe, you know, but you cannot produce evidence. Whereas with the other approach, you can say it and even produce evidence. So no evidence based on statistical sampling theory. So you can only, you can only generalize to the population where you drew the sample. Sometimes we say we like to make statements like this because even me as a statistician, when I have to work with researchers, sometimes we just tell them to say, if I get this, my results, they are applicable to a population that is similar to mine. So if I get another population that is similar to mine, this result would be applicable. So whatever the population, if I get it, this result would be applicable. So those are the limitations, but I mean, we continue to use convenient sampling and we highlight the limitations, generalize where we can, where we can't, we just stop there. So in summary, when you are selecting your sample, you are guided by this: the purpose, the design, there is the theoretical population, and then the population that you have access to. Because there might be this population that you want for your study, but you find that you don't have access to it. So practically, you now have to amend everything to talk to the population that you have access to. And then is there a sampling frame that will influence the approach you take? If there is no sampling frame, automatically you have to take the other approach if you cannot create one. We've covered what is a sampling frame. We've spoken about coverage errors, and then that there has to be a one-to-one correspondence between the units on the frame and the units in the target population. So if in the population I have 50 enterprises of size 1, meaning the big enterprises, even on the frame, I need to have 50. If I have so many thousand medium enterprises, even on the frame, I need to have those, and so on and so on. And then in terms of now your sampling process, this is a process that you can follow where you define your population, you do your frame, and then you specify the method that you will use, and then you have the sample size, and then you implement. So in the next workshop, we will cover how do you now estimate the sample size. I have this exercise as a parting shot that I would like us to do. So I'll just give you some time to, we can take questions and we can also attempt to do this exercise. It's 6 questions. So I'll give you a chance to look at the 6 questions and then apply your minds. Please do engage so that we can, so that we can see where we are, if we understand the concepts or not. So please do share your thoughts, please.